Hello, this is Andrew Gaines, Head of CIBSE Certification. I'd like to welcome you all to this, the latest in our webinar series. Just a quick bit of housekeeping before we start. We normally get questions during the webinar asking about the slides. Both the slides and a recording of the webinar will be available on our website sometime tomorrow. It takes a while to get the recording, but sometime tomorrow it'll go on the news section of our website. Okay, on to the detail of the webinar. As you can see from your screens, whole life costing for sustainable development, or maybe whole life value, presented by Mariana Trusson, who's an Associate Director at Hurley Palmer Flatt, but probably better known as the author of the bestseller of the same title as the presentation, funnily enough, though actually the original title was Whole Life Costing for Sustainable Building. So that's the title of the book. Any more detail than that, I'll hand you over to Mariana.
Hi, thanks, Andrew. I'm Mariana. As Andrew said, I'm a chartered engineer. I've been working in the sustainable building sector for about 20 years now. I'm presenting today on the concept of creating the business case for those tough sustainable discussions that seem to make perfect sense in the cold light of day, but that end up forgotten when financial and technical business cases are put together. So instead of having really nice concepts end up in the dreaded nice to have pile in the design process, and then get them relegated to the too expensive pile during value engineering, and then seeing them magically make it to the top of the list of why this is not included during the occupational phases of the building, we're going to try and make the business cases stick from the get-go. So after years of serving and helping design buildings from Ullapool to Bath, I decided to nail my colors to the mast and write about processes that can help build better cases for sustainable building design. So as Andrew said, the book is titled Whole Life Costing for Sustainable Building. It's about realizing value through basically calculating costs as but also carrying out a multi-attribute analysis of good practice. And this bit needs a bit more discussion in the buildings industry. So I'm hopefully going to start with it. So I'll start by giving a little bit of context to what I'm passionate about. I'll discuss some of the basic decision-making processes, tackling it from an engineer's mind, from first principles. I will give a little insight into the how whole life costing is integral to building procurement, both for new buildings and major refurbishments, and how it is key when assessing investment scenarios for estates as well as individual buildings. How standard whole life costing methods combine capital costs, facilities costs, operational costs, income and disposal costs with a single action, single benefit approach. And also how costing based on this type of single attribute assessment misses out on realizing value from the intricacies of the interactions buildings have with their occupants, their users, and the location in which they are placed. The presentation will explain how the multi-attribute approach I am advocating analyzes the whole cost of the building, while also taking into account secondary and tertiary values of a variety of actions that are deemed important for the project owners and decision-making stakeholders. I expect that you will leave with a view that the process is an effective tool for presenting a good business case within the opportunities and constraints of real life. I will even go through in a couple of examples of the interdependencies between building location and occupant satisfaction, material selection, and overall building quality in the environment. So there are a number of standard methods and documents on the subject of whole life costing. BS ISO 15686, the HM Treasury Green Book, the Office of Government Commerce OGC Procurement Guide, and so on. The common theme in all of these is the treatment of single items, such as the building design, the building fabric, lighting, and mechanical services, as having a singular cost implication in terms of capital costs and a singular implication in terms of operation or maintenance requirements. But the assessment of associations for each cost item should include the effect systems have on each other within a functioning building, because in real life, we all know this is how it happens. Off the paper, the choice of glass for windows in an office building will affect occupant productivity and the occupying company's bottom line just as much as it will affect the energy performance label for the building as a whole and its subsequent marketability. So, not just looking at capital costs. But these considerations are not catalogued or noted anywhere when someone offers a cheaper alternative at the 11th hour. Often this is because they are not recorded clearly during the early design stages. This is why the true impact of design choices, as they would be in real life for living, breathing buildings taken as whole interactive systems, needs to be illustrated methodically across all the design stages, openly and comprehensively. So my experience through hundreds of projects today is that for the majority of projects, decisions are skewed toward short-term financial metrics, with aspects such as the whole life cost of projects added on as a check after the major decisions have been made. And as a general rule, they do not seem to compare all the options tabled by the professional designers in a manner easy for the comparison. For example, speculative developers base many decisions on the opinions and metrics laid out by property agents. Many clients seek voluntary targets in the form of certification, only if they might give a market advantage, and often in design processes, technical feasibility is overruled by short-term cost metrics. Additionally, in early design, environmental decisions are limited to regulatory compliance only, otherwise known as planning requirements. A standard example is the choice and use of inferior quality components to save upfront money. The justification generally is the function is the same. The costs tick a box, even as quality and longevity and long-term considerations are labeled as those nice-to-haves. Carpets, for instance. Cheaper options are chosen based on cost alone. They then need to be replaced within 2 to 3 years because the function may be the same, but quality was not. I don't know about you, but I would not expect to change the flooring in my house or office every 3 years, yet developers or agents don't disclose the details on sale. In reality, for a small initial cost increase to get the quality and longevity right, the long-term cost implications are reduced dramatically. More difficult and controversial examples of such practices make it to the news and sometimes cost lives. This is when cost-effective alternatives are chosen and approved for buildings that in time prove downright dangerous. This leads to legal minefields, the need for government to issue yet more legislation in a hurry, and technical professionals coming under fire for failing to make their voices heard. But the conversations were rigged, and cash and short-term thinking reigned supreme. And this is how choices are skewed. The alternative is balance. So conventional cost-benefit analysis of resilience measures are heavily loss-centric. They tend to weigh up the certain cost of investing in resilience against the uncertain benefit of avoided losses. This can result in decision makers underestimating the benefits and avoiding the unknown. In truth, increasing resilience reduces the background risk of disasters, and as a consequence, individuals and organizations can be encouraged to become less risk-averse. This means they will tend to undertake long-term investments in productive assets, engage in entrepreneurial activities, and lengthen their planning horizons. All of these are undoubtedly needed for sustained economic growth and development. This is crucial if we're to proactively take advantage of structural changes in the global economy and of new market opportunities and to develop new market niches. So within building procurement, this looks to a more balanced approach to decision-making from the very beginning. with aspects given due consideration and processes in place to acknowledge longer-term impacts and benefits. So reaching a preferred choice gives appropriate weight to short and long-term financial considerations, as well as their technical and environmental implications that includes functionality and performance and use, as well as client and stakeholders' voices. So the process starts by remembering and acknowledging what a building is for. It should be something beyond simply a financial asset, a number on a spreadsheet, or a profit-generating blip on a company's chart. The basics such as shelter and retreat are obvious. It's not a building unless it's weathertight. But aspects such as longevity, resilience, and adaptability seem to fall through the cracks, with many developers requiring building life to be limited to 30 or 50 years to account for profits. And I would interject that history shows that truly successful buildings last, and building failures are all too evident across the world. So successes include the Pantheon in Rome, which was built as a temple by Hadrian in 117 AD. It has been in continuous use throughout its history. It is one of the best preserved of all Roman buildings, and it's now a museum and Roman Catholic church. The Nanshan Temple is a Buddhist temple in China. It was built in 782 AD, and it's currently China's oldest timber building in existence. Failures are plentiful. The Harmon Hotel in Paradise, USA, was demolished within only 6 years of its completion. And the Gallagate twins, otherwise known as the Kalmaki twins in Glasgow, were demolished because they were understandably an unpopular place to live and had extremely high maintenance and running costs, as did their siblings and cousins built across the UK at the time. So nonetheless, the impact of longevity is often underestimated, both when considering long-lived buildings that are proven to contribute to improved sustainability and profitability, and short-lived buildings that are an environmental and running cost nightmare. This isn't to say that we should not account for the business side of the equation when considering how and why we create buildings. But even then, it is important to look at aspects beyond just numbers, such as well-being, productivity, customer experience, flexibility, and adaptability. Even employee or tenant retention, which links to growth and financing. Balance is key. The more aspects we consider for whole life valuation assessments, the more informed and balanced decisions can become. So things like total ownership costs, including capital and cost in use, are only the tip of the iceberg. So balance looks to consider things like attributes of a building that affect its perceived quality and effectiveness. They may feel like opening a can of worms, and obviously not all will have the same importance or impact. So we should do some second-level analyses. The detail with which aspects are assessed depends on the stage of the project. At earlier stages, higher-level attributes will need to be considered, whereas later on, more of the detail will be needed. So I need you to take you a tiny step back to explain some basic costing aspects. So, what is whole life value and what is whole life costing? Whole life costing is affectionately termed as the economic assessment considering all agreed, projected, significant, and relevant cost flows over a period of analyses expressed in monetary value. Basically, according to the National Platform for Built Environment, it's the systematic consideration of all relevant costs and revenues associated with the ownership of an asset. But what are those? Total cost of ownership is the whole life cost, including disposal and end-of-life costs. But you see, that's not all. This is different from life cycle costing, which doesn't include income and externalities or non-construction costs. Externalities tend to be both positive, like public health and safety improvements, and negative, like environmental pollution. Examples include things like productivity effects as well as government taxes. For example, the Greater London Authority's carbon tax can be considered an externality. And whole life costing also includes non-construction costs, which are the initial capital costs such as land acquisition, pre-construction design, consulting costs, permits, insurance, and not to mention any income from buildings. Whole life value, on the other hand, includes your whole life cost, as well as functionality, social impact, quality, time, and regulatory compliance. It puts a lot more meat on the bones of those externalities and brings to the fore some aspects not often considered, but that are equally important. In simple terms, whole life value of an asset represents the optimum balance of stakeholders' aspiration, needs, and requirements. The M under MWLV stands for multi-attribute, which we will get to in a second. It's worth noting that life cycle analysis comes into this category, and it is different from life cycle costs, because life cycle costs incorporates the costing of the model, whereas life cycle analysis incorporates the carbon effect. Most people involved in BREEAM projects have found themselves confused over these acronyms. LCC and LCA often get confused, and hopefully I can clear this one up. Life cycle analysis is effectively a set of procedures. It's used for analyzing the inputs and outputs of materials and energy, directly attributed to the functioning of a product or service throughout its life cycle. It's usually expressed in non-monetized terms, and it's focused on carbon equivalent impact. So your most common life cycle analyses that most property people come across are in the BRE's Green Guide, which is a database of LCA of a variety of construction products. But there are many more detailed and expanded procedures that take into account the environmental impact of materials from cradle to grave. So there are benefits to choosing the more complex options. In essence, developers and owners are able to make well-informed evaluations of competing options. Multi-attribute whole life value is relevant to most equipment purchasing decisions, whether simple or complex, and the technique is also applicable to leasing decisions. They have a higher awareness of total cost, whereby the whole life costing aspect provides buyers and decision makers with a clear understanding of the factors governing costs and the resources required associated with each purchasing choice. So the decision makers can make better forecasts, as whole life costing allows the full cost of a purchase over a period of time to be calculated with reasonable accuracy. It helps develop more accurate long-term cost assessments and promotes realistic budgeting for operation, as well as maintenance and repair. This is of considerable importance when major investment decisions need to be made. They can make performance trade-offs against cost in a less risky way, because the process provides a more holistic approach to considering proper value for money. The costs, quality, benefits, and broader issues are included. Clients can balance needs against preferences, thus managing aspiration in a rational and auditable manner. As with all things, stakeholders need to be able to buy in, and by addressing requirements transparently at every stage, they are able to maintain stakeholder support throughout the process. Additionally, the process itself creates and maintains useful and reliable benchmarks, which can be used by the rest of the industry, or developers can use it internally for the next project. And okay, there are a number of downsides. This analysis, as with all predictive methods, is based on assumptions. Although these are well researched at the initial stages of a project, they need to be revisited at every iteration to ensure that they are still relevant and logical. This can take some time. This is a long-term analysis, and we live in a rapidly developing global economy. trends, market forces, and regulatory requirements, technical breakthroughs, times in general can change within the serviceable lifespan of a project. To remain valid, realistic, and reliable, the whole life value model needs to be updated as significance influences change. For example, a few of the parameters that are likely to change within the lifespan of a building and will affect the final outcome of a model include procurement and finance, fuel costs, weather extremes, safety regulations, all these sort of things. All aspects of procurement need the bill payer's permission. So whole life value is a long process that in many respects need to be undertaken by specialists. It has a cost that in many cases can be justified by the savings identified, but the analysis is complex and decisions need to be taken at many stages along the procurement, ownership, and end-of-life journey. So bill payers really need to give much more than their permission. Whole life value needs clear and strong buy-in, and sometimes this can be considered a weakness. If this is the case on a particular project, then this process is not for that project. But if your project is still game and looks into how this balanced decision making works, we can go through what it looks like in practice. So let's look at an example of incorporated decision making, taking these multiple attributes into account. This is for site selection. The yellow boxes state the main aspects for consideration set by the buyers: costs, location, access, environmental, and planning requirements. The grey boxes show the aspects associated with additional issues within each priority, such as tax burdens under costs, availability of materials under location, transport facilities under access, air quality under passive design, and flooding under environmental. And the list of yellows and greys is not exhaustive, but in this case, this is the one that we used. Most of the times, these are self-evident aspects to consider, but listing them and reporting against them becomes necessary if a true account is to be made of the weighting each of these aspects has on the decision. For example, for a particular project, the risk of flooding may outweigh the ability to procure materials locally, hence the need for appropriate prioritization. To set priorities, we need to understand the project as a whole, its aim, its values, the key design and financial parameters, who the stakeholders are, what skills are available to us, and how collaborative the overall team is. The aim of the project, for example, will determine the overarching goal for any assessment. Some illustrations. To procure a good learning environment at as low a cost as possible, to deliver X number of domestic properties suitable for all stages of life within Y budget by Z year, to restore and repurpose a historic building to provide homes, retail, and office space with stunning architecture whilst retaining the character and features of the existing building. So getting the aim or goal tied down is really important. And making sure these goals are clearly stated and accounted for is important to help keep everyone's focus in the right place. For example, reduced cost in the medium and long term, following through on whole life costing findings for overall project costs, reduced risk, plan and budgeted maintenance control, continued compliance, constructing a building that improves the occupier's business performance by designing from an asset performance requirement, informed and standardized decision-making, improved accuracy of asset life projections, to demonstrate value in terms of a client's own criteria, to retain building value beyond the effect of market forces, aligning component selection with planned maintenance and renewals and supply chain engagement, support economic and social and natural resource sustainability goals. The list goes on. The project values will help keep the project on track through the changeable process of design and construction. There needs to be at least 5 of them, but more if preferable as they provide an insight into the real drivers of the project. So some examples: value for money, high efficiency, attracting higher quality tenants, longer building life, productive learning, high occupancy ratios, and so on. Interestingly, in an Australian study on sustainable buildings, it indicated that 100% of the survey respondents believe that sustainable buildings will outperform traditional buildings in the medium to long term, but they didn't necessarily believe that in the short term. So project values need to be ranked in order of importance and associated weightings, and the associated weightings need to be allocated. As the project progresses, these values will be revisited, and once trivial matters will either be disregarded altogether or they may rise in importance. Conversely, items that were critical to begin with may drop down the scale later on in the process, depending on the inputs from other stakeholders. So the project owners also need to decide on some overarching targets and design parameters. This will inform the brief that the design team works to. So some examples include low environmental impacts of materials, such as low impact life cycle assessments, adaptive thermal comfort limits, whereby the building is expected to be thermally comfortable for 95% of its occupants at any one time. There will always be outliers on this one. High coverage for telecoms and IT infrastructure, such as a wired score rating, certification, as we said, your LEEDs and your BREEAMs, and accessibility, and that's not just EDA, and so on. Setting and making clear the total capital budget is also crucial. If possible, it should be split into design and construction costs to help identify the value at stake in the later stages. It should be noted, although you all know this, that the cost of professional services such as advisors, specialist consultants accounts for under 2% of the whole life cost of a project. Yet the quality of the services has a direct impact on the other 98%. So I'm preaching to the converted, I think, when I say it really does not pay to be stingy on expertise. Obviously, operational budgets will also be critical. Splitting them down to running costs and maintenance cost expectations allow better decisions. And preparations for future cost cutting will need to happen at this early stage. Although to a great extent, the prioritization of the various parameters discussed will help aspects such as ring fencing of budgets and costs needed to be confirmed, and keeping away from the dreaded value engineering. Okay, so my pretend project number one for today, whereby an entity would like to consolidate a number of office spaces spread across one large city into one building. We have identified some variables, as we said. The prioritization of these variables will also depend on the individual decision maker. So the decisions are initially prioritized as follows. As you can see, the weightings used in the examples here are what are termed verbal weightings, but take into account all previous parameters associated with the following statements. Critical at 100%, very important at 75%, important 50%, unimportant 25%, and trivial 0%. So financial performance and occupancy are critical, location and timescales are very important, transportation and aesthetics are simply important, and flexibility is unimportant to these guys at this stage. So the priorities are set, but we're not yet done. There's no right answer when it comes to prioritization, and it has everything to do with the stakeholders. Value charrettes are an excellent way to do this. However, getting the right people around the table and making sure that they have the right skills to make the decisions is also important. So taking a look at those at this stage is good. Information and decisions on the aspects discussed will be required. So client-side stakeholders, this is your list. They're split into some logical groups. Specialist advisors are considered client-side. These are external consultants that provide specialist advice directly to the project sponsor or owner. So they include accessibility champions, sustainability champions, and they're tasked with monitoring and keeping track of project process. The client team, oh, I missed one. There we go. The client team also needs some skills. They need to understand the process, and when those skills are missing, generally specialists need to be called in. So on the project procurement side, it's important to understand the management abilities needed. And the list is long. You need to understand the construction industry if you're a client trying to procure a building. You need to understand things like risk management and business case and investment appraisals. They would generally have that, but not necessarily contract strategies when it comes to buildings, not necessarily estate strategies and so on. And understanding claims is a big one as well. But when clients don't understand all of these things, they might need a translator or a champion, again, to help them do that. On the project delivery side, these are your project stakeholders, your project manager, which is sometimes your architect, sometimes an individual organization, consultants, contractors, and so on. Setting a communication strategy for these stakeholders is absolutely imperative. It may be that certain groups meet at certain stages or that others are required to report at specific intervals, but the strategy will dictate who and when makes decisions and how these are communicated. And the project team needs skills. I've got it at the very bottom, but I think the most important one is collaborative working, because then you can share these skills within the team. Other things that are necessary are things like forms of contract. In this day, embodied carbon, climate change, energy supplies, and so on. So on to the analysis. We got the right people, we had them around the table, and we can make the analysis of the priorities identified through the project. In one of our exemplar projects, there are 3 available sites, A, B, and C, under consideration for the consolidation, and they're characterized per variable. So we'll assign some further weighting. So yes, 100, maybe 50, and no 0, and we'll analyze. Underneath those variables, this is, as you can see on the table, what we came up with. Now, there are plenty of standard analytical hierarchy processes on the market, and some are fancy and have pretty colors and make pretty graphs at the touch of a button. I have set this in an Excel spreadsheet because the other ones are just too fancy. So the analysis showed that C is marginally more favorable than B, and both are much more favorable than A. Basically, site C does have more going for it. It will be completed on time. There is sufficient transport infrastructure to get people to where they want to get to. It will be in close proximity to where all the previous offices were, and it can be expanded if the need arises. However, it cannot accommodate all known employees. And this particular example is taken from a real-world example a couple of years ago. The decision was made to implement flexible working patterns through shared desks and remote working, for a percentage of the staff. This allowed a smaller building to be built. With respect to the capital budget, it was realized that the affordable option, which was B, was not as fully compliant with all the parameters, and so a new business case was made and accepted for additional funds to go with site C. So if we hadn't necessarily written all of this down and went about it in a logical manner, in most probability, site B would have been chosen because it was the cheapest, but ultimately C is the best performer overall. And because of that, more funds were released later down the construction process, once agreements for site purchases were reached. Okay, let's look at some other examples. How whole life value can be used as a backbone against which to explore and assess the whole life sustainability of any program and subsequent outputs. So it can be used to provide insight into full building utilization, which translate to increased working capital for any organization, as well as some residential applications. So using space utilization survey results when considering new buildings, a university campus could lead to the procurement of smaller buildings in situations where existing building occupancy is consistently below 50% and overall utilization is below 20%. So in very broad terms, taking building occupiers and their behavior into account and prioritizing aspects such as productivity and flexibility could save a university as much as 50% of its building expansion master plan budget, and that's a really big number. This means that more funds are available to look into other aspects of design, such as climate change adaptation. Conversely, when utilization is not taken into account or it's not prioritized appropriately, or where the analysis is not clearly addressed, it's clear that the project can result in simply spending money and sending it down a pit, and the proliferation of empty buildings. If we take this approach at a later stage of the design, we could pick materials as a priority. Here, the project values are costs, maintenance, environmental, buildability, and waste. Expertise is required for some aspects, such as environmental and waste criteria, whilst others can be assessed by your common or garden design team. So to help in this case, experts can be invited and appointed to carry out, let's say, the life cycle assessment. This is what one looks like. I made it earlier in a true Blue Peter style. In and of itself, it looks at multiple attributes, all on its own, materials, their origin, their transportation, their replacement, their end of life, and it's split into material types, and you can split it by mass as well. So now that we have the correct life cycle analysis data, the team can carry out an options appraisal taking out into account the QS's cost analysis. So there are 3 available options again, A, B, and C, and the same weightings that we used before. So it shows that overall option C, I promise I don't do it on purpose, may not be exactly to budget, but the environmental benefits and buildability aspects, which could reduce time on site, do weigh in favorably compared to just the cheapest option. Further discussions are definitely needed to assess the maintenance aspect of this, as perhaps additional actions can be needed. For example, window cleaning processes and CDA considerations need to be taken into account. But this is why the conversations and collaborative working skills in the team are really important. So, bringing it all together, almost. To reiterate, documenting the prioritization process and making sure these goals are clearly stated and accounted for is important to help keep everyone's focus in the right place. Adding weightings to identified project values will help keep the project on track through changeable processes and design. Finance will always make the cut, but there needs to be at least another 4 priorities in the frame as they provide an insight into the real drivers of the project. Intricacies and interconnections need to be considered and experts brought in when there is a skills gap. The process of whole life value is intended for project teams that want to go beyond the basic compliance or simply meet legal requirements. It's an effective tool for presenting a good business case within the opportunities and constraints of real life. Regardless of the uniqueness of each project, building projects in general have extended commonalities, and the differentiator is the importance placed on each of these. So this is a list of common priorities to consider. I really do not want to have a final one that says pandemic. I really don't, and I won't for a while. Clearly, financial makes the cut. And any financial models can be used, but they need to be clearly identified and consistently used throughout. Things like net present value, standard payback, discounted payback, internal rate of return, probability index, and the ISO lifecycle costing, the LCC that we referred to. I think simple payback is the most common when looking into relatively smaller investments, but they tend to be the least effective method for analyzing value. Unfortunately, they seem to be the one most quoted for excluding things like really useful design aspects. The environmental models that are used should be decided upon early as well, and they need to be consistent throughout the project. There are a shed load of assessment tools to be chosen. Assessment tools in general adopt one of two assessment approaches: bottom up, which is the most common, and it focuses on building component and material selection. And when using this, tools tend to estimate the environmental impact of the operation phase of the building and distribute it across building materials and components. And then top down, this considers the entire building as a starting point for further improvements, with initial considerations focusing on form and size and considering material and systems afterwards. So the further down the design process we go, the greater the interconnections between variable and priorities we tend to encounter, daylight being one of the simplest. If it is a priority, as it will be for schools, offices, residential buildings, hospital, etc., then it needs to keep being a priority as things change. And so the reasons for prioritization need to be documented to keep in focus. If its priority reduces, then this will impact aspects of the building, such as building desirability, sale and resale values, aesthetics, effectiveness, productivity, and maintenance. And to make sure that good daylight is achieved in practice, then all of these factors need to be earmarked for prioritization as well, such as location and solar gains and plan and room layout and lighting controls, and the list is large. But then these factors will also affect a number of other areas in the building, and this needs to be documented too. If anything, this interconnection and complexity indicates that decisions should not be taken lightly, that simply stating in a brief good daylight translate to dozens of effects that need to be addressed appropriately and effectively across the project stages. Hence prioritization. It is unrealistic to assume that the client will know what these are instinctively, just as it is unrealistic to assume that the professionals on the team alone will be able to anticipate the importance of all the variables. This is why the round table discussions can't just happen disjointedly at sparse intervals. Rather, the aims and ultimate goals of the project need to be reiterated during most, if not all, project meetings when decision makers are present. because as the design gets more detailed, so do the links and variables. So this is why the whole life value assessments cannot simply happen once on the design, rather they are needed at each important stage. And they are live documents changing as the design evolves. The main point of contact with the assessment process should be the project inception, feasibility, appraisals, planning, value engineering, construction, operation, maintenance, decommissioning. It generally requires clear thinking on objectives and service requirements whenever it is undertaken. And so whole life value assessments and hierarchical structures for important project values need to be visited frequently. So this is a simple hierarchy structure for a more detailed building design stage. Again, the primary project values, first level, 7 in total, remember 5 is the minimum, are used as a basis for evaluating the design. To help with these values are expanded to include slightly more detail. There's 22 of those in total. And where necessary, a third level is included to reflect any intricacies. In this example, it is included in under maintenance and a further 2 criteria used to assess alternatives. In addition, not all of the codependencies are also shown with connecting arrows. These are used to help with the weighting of certain aspects. For example, occupant well-being is shown to also depend on extension on energy, because they might want more heating or cooling or whatever. Modeling and servicing strategies depend on modeling depends on servicing strategies, environmental depends on servicing strategies, and so on. But if weightings are decided upon effectively, these interdependencies can be deemed to be accounted for in the process, and so omissions of design are avoided. So the approach applies to the building as a whole and to components individually. You'll be happy to know we've come to the end of this process, and my attempt to simplify, I hope, has worked. I hope I've given you a little bit of insight into the effective building design decision-making. I believe I've given an insight into how decision-making based on multi-attribute approach works. I hope that you have a view that the process is an effective tool for presenting a good business case. And thank you for listening. And before I go, I will leave you with some gratuitous advertising. There you go. Andrew.
Okay, thank you very much, Mariana. A lot of information there. Too much for me at some points. On your last diagram there, I was looking in the yellows and blues for energy, thinking it must be here somewhere. And of course, it was in the front line in the grey. I got there eventually. Okay, so we will, we've got time to run through any questions. If anyone would like to use the chat facility to drop a question in, I will try and get through those questions. We do have a couple of questions already. Early on in the presentation, Mariana, you mentioned value engineering and you qualified it with the word dreaded. In the Hackett report, value engineering got a bit of a slating. So, what are your views on its use? Why the word dreaded?
I think it's because value engineering doesn't actually identify value, as I think I've explained here, that value has many parameters, and unless all of these parameters are identified, then when you try to cut costs, you're not cutting them by taking everything that you could do into account. And I think the Hackett report shows that, and a couple of other reports of similar problems show that. Hence the need to make sure that things are documented and that all priorities are taken into account.
Yeah. Okay, good. Thank you. And oh, this is interesting. Do regulatory requirements often lead to solutions that do not give lowest life cycle cost or best whole life value?
Yes. That's an easy answer, isn't it? Yes, because regulatory requirements, again, are only part of the overall picture that needs to be taken into account. So I'll try and find the slide that shows that, but it only forms part of the aspects that need consideration, and so it doesn't necessarily cover things, and things go on to regulation. For example, you know, we have regulation for insulation and incorporating insulation, but it doesn't necessarily cover the aspect of overheating in the summer, because what they're focusing on is prioritizing reducing the heating load. So someone else needs to think about that.
Yes, that's a good example. That's one of my pet grumbles, particularly retrofitting to improve energy performance of buildings by putting in internal insulation in and losing the mass of the building. Okay, so sometimes you're working backwards after satisfying regulations to try and get the best solution without upsetting the original approval.
Yes.
Yeah.
So yeah, so these are common priorities, and regulation is possibly in there, but no regulation looks at all of these priorities or takes all of this into account when they're put. They're just focusing on plugging one hole or putting a plaster on one problem without necessarily assessing everything else that goes into it.
Yeah, yeah. Okay, well, thanks for taking those questions, Mariana. That is all the questions we've had today. So that was obviously a very comprehensive presentation.
It was a stunning presentation.
Yeah.
Silent.
The next webinar won't be quite so exciting. We do have the bare bones of our September webinar in the planning stage. I shouldn't say it won't be so exciting, should I? Not so exciting, but essential listening. We do have a new energy certificate register going live on the 20th of September. So we're planning a webinar a couple of days before that date to be confirmed to run through the implications of that for anyone who is involved in lodging energy certificates. So watch this space for more information, and thank you all for attending today. As I said, the slides and the recording will be available on our website from tomorrow.
Thank you.
Thanks all.